everyone. For the last video, we have talked about Lagrange's interpolation formula. For this video, we're going to talk about numerical integration. Now, what exactly is numerical integration? We got some set of tabulated values from the function fx. Now, from that tabulated value, we would get an definite integral. We would evaluate that integral to get the numerical integration. Now this whole process is known as numerical integration. Now the process that is applied on the function fx of a single value. Now this whole thing of fx is known as quadrature. Uh, the problem of numerical integration can be represented by fx, which fx often by an interpolation method. All the interpolation method that we have learned till now will help us in representing fx and integrating the limit between all the fx values. I mean, we have fx for every other term of x, and so we would integrate the limits between them, and through that we would derive quadrature formula for approximation integration of a function defined by a set of numerical values only. And how do we now derive the quadrature formula? Let's see. Uh, in This is a proof that uh, for the quadrature formula that we're gonna learn about, we firstly take I value. I firstly take the integration of fx is equals to dx. Uh, fx is equals to dx with the limit of b and the limit of a. Now we take an equation. Where did it go? We take an equation of x is equals to a plus hu. A plus hu would, we take an equation like this, we differentiate it as dx is equals to h du. It would differentiate in this manner, and then we take x at the value of a. Limit a, we have taken here a. The same way we would take x is equals to a. Now a, when we take a, so we could say that a is equals to a plus hu from this equation, this equation that we have taken. And from this we could say u is equals to, we would equate this, and then we would get the value of u as is equals to 0. Now again we would take another equation, x is equals to a plus nh. We would keep the a plus nh is equals to a plus hu from this equation. A is equals to a plus hu, and with that the a of both the side would be cancelled, h of both the side would be cancelled, and we'll get the value of n is equals to h. Now we keep the value of fx as fa plus hu with the limit of n and 0. Okay, and for the next thing we will do, um, just a second. For the next method, we would go for h n by n from n to 0 f a plus hu dx. How did we get here? We knew that dx is equals to h into du, and so we replace the dx uh, with h into du. And so for the next we would expand it. Now this whole this this equation will be expanded with the help of Newton-Gregory forward difference. Here, if you remember, we already did the forward difference interpolation, Newton's forward interpolation. which I told you that Newton forward difference is also known as Newton-Gregory forward difference, and so we would expand that this formula, this I is equals to this formula of I is equals to h fa plus hu dx would be transformed into this whole formula. It would be expanded with the help of Newton forward difference, and with this um, we would actually replace the all the h u, and the u's is then we integrate the whole thing. Obviously mean this was in the integration, and now we would open do the integration, which would get us equation like this, and then we would replace all the values of u. I mean, for the next step of integration, we always put the limits inside all the variables, and so we put the n value, value of n, value of n in the formula. I mean, the u was replaced by n, as it was the first limit, and 0 we have already calculated that. Huh. So after equating the whole, I mean, we already calculated this, the this whole equation, opening this where and replacing all the u value with n, as we know ki, n is equals to u. We have seen at the starting of this proof, and after this we would get a generalized form of the whole formula, which is this: I is equals to nh fa plus n2 delta fa by 1 by n square by 3 minus n by 2 n delta square fa plus 1 by 6 n cube by 4 minus n2 plus n uh, 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 delta cube fa. And this is the generalized form of the whole quadrature formula. Now the quadrature formula is, and this is how the whole, I already told you what was quadrature. Quadrature was the, when we use the integration in the function, it becomes the quadrature. And so this is the generalized form of quadrature. With this we could say that we already did the numerical integration. This was the proof for quadrature formula. For the next video that we have derived is also known as Newton-Cotes quadrature formula. And now on to the next part, that was trapezoidal rule. In trapezoidal rule, we would put n is equals to 1 and use a straight line, where we would ignore all the higher order degree other than the first one, and we would just put the values as we have seen here. As in the we would put the we would put 0 in case of all the higher order, um, higher power terms like the delta square and the delta cube. We would only be only left with f fa plus half of delta fa. Now we would just open the first forward difference formula and just simplify it throughout the process. After simplifying it, we would just uh, change the formulas with y not in y1, with For we would get every other term for y. I mean, we would get a y not value, we would get y1 value, we would get a y2 value, y2 value, and so adding all such terms, we would just create a generalized term that is known as trapezoidal formula. You could see here that we have created um, for generalized form that is trapezoidal. And onto the next part, which is when we keep n is equals to 2. In the general quadrature formula, that was also known as Newton-Cotes quadrature formula. Here we would just ignore all the degrees after the second degree. I mean, from the third degree of delta, we would just ignore them, because we are ignoring them, we only left with the terms that are terms left until second degree. We would just as always, we would just simplify all the values of fa and keep the value of n. After keeping all such values and simplifying it, we would get a value, get different terms, like here, like I is equals to h by 3 fa plus 4h, 4fa plus h, fa plus 2h. With this, we would just transpose all the y value, the values of f function with y. And after doing this, we will just add all the terms that we have got and create another general formula, that is Simpson's 1 by 3 rule. As you can see here, another general formula that we have created. For the next one, we have n is equals to 3, which is Simpson's 3 by 8 formula. We will just ignore every other high value after uh, delta to the power 3. As we are ignoring them, we would be only getting the value till delta cube, and again we would just simplify all the fa values, and after putting the n is after putting the value of n, and doing so, we would change the value of fa by y terms. Um, Getting all the y terms, and after replacing all the y terms, we would just add them, and create another general term, that is Simpson 3 by 8 rule. For that, so that is it for this video. Thank you for watching this video.